Assalamualaikum warahmatullahi wabarakatuh and selamat sejahtera. Today we're going to continue with chapter 6, circular motion, where circular motion have two subtopics. The first one is uniform circular motion and second subtopic is centripetal force. In 6.1, we are going to describe uniform circular motion and convert units between degrees, radian and revolutions or rotation. In this lecture, we're going to introduce the unit and introduce the related physical quantities. Okay, uniform circular motion is an object move in a circle with constant uniform speed. Magnitude of its linear velocity remains the same, which means the speed remains the same, but the direction of the velocity change continually as it moves in a circle. Uniform circular motion is divided into two planes, horizontal plane and vertical plane. First example is a ball swung in horizontal circle. Second, a car or a motorcycle turning a corner. Third, for horizontal plane, a cone pendulum. And last examples for horizontal plane is a merry-go-round. While for vertical plane, first example is a Ferris wheel. Second is a roller coaster. Unit conversion between degrees, radian and revolutions. One revolution, which means one circle, is equals to 360 degree or equals to 2 pi radian, where one revolutions, one circle is equals to 360 degree. 360 degree equals to 2 pi radian, or half circle 180 degree equals to pi radian. To convert radian to revolutions, you will have 2 pi radian equals to 1 revolution, or we call it as 1 rotation. Okay. First physical quantities that is related to circular motion is angular displacement. Angular displacement is the angle through which an object moves in a circular path. So angular displacement, we are talking about angle, where the angle is calculated between the initial and final angles. Unit for angles in circular motion must be in terms of radian. So when you have theta given in degree, you have to convert it into radian. Example. So as the object moves from P to P1, this is your angular displacement, your theta. Theta is equals to S over R. So S comes from the displacement here. Example, 300 degree. Angular displacement 300 degree is equals to, so one complete cycle, 2 pi r, where this is the circumference, 2 pi r over r. 360 degree equals to 2 pi r radian. For small change, we are using change of angular displacement equals to change of displacement per radius. Angular velocity omega. Basically, you can relate with linear, where we have v equals to s over t. For angular velocity of omega, omega you will use delta theta over delta t. Omega is defined as the rate of change of angular displacement. So the unit will be radian per second, or other units for calculating omega is RPS, revolution per second, or it can be revolution per minute. But the SI unit must be in radian per second. It is a vector quantity, so you need to determine the direction, and the direction is determined using right-hand rule. The direction of the angular velocity omega depends on the rotation of the object. It's either clockwise or counterclockwise. Third quantity is a linear velocity, v. So from a formula of angular displacement equals to s over r, you can determine the linear velocity. You can determine the linear velocity by dividing both sides with t. When you divide s displacement over t, you will get v r delta theta over t. So delta theta over delta t is your omega. You will have r omega. So velocity, linear velocity equals to r omega. Unit for v equals to ms negative 1, where in circular motion, your linear velocity is the tangent of your object motion. So it's a tangential velocity. Number 4 is period. Period is defined as the time taken to complete one cycle. So, the time taken must be time taken to complete one cycle. Number 5 is the frequency. Frequency is defined as the number of revolutions completed in 1 second. The number of revolutions in 1 second. So, the unit for frequency is hertz or per second, and the equation of frequency is equals to 1 over t, 1 over period. How to relate between velocity and frequency? Velocity can be related with frequency using a formula of 2 pi r per t. 2 pi r is s for one complete cycle, then over period equals to 2 pi rf. Because here, when you have 1 over t is equals to your frequency. Angular velocity, how can you relate between frequency? Angular velocity is equals to 2 pi over t or equals to 2 pi f.